Hi everyone, welcome to another stream of the DCSS AI Wrapper project. All right, I'm live. So last time we had solved an issue on GitHub, and so if I just pull that up here, GitHub. We just look at this here. We go to issues. We had closed this out, but if we look at the closed issues here, I think it was this one. Yeah, number 19. So there were some PDDL issues, and so we're just going to verify that we fixed this. And what this means is that we should be able to have an agent that can go to stairs. So what we're going to do is we're going to run the planning agent. First thing I have to do, let me make sure you guys can see the terminal. Nope, not that one. Not that one. Just give me a second here. Okay, this is it. Awesome. So we have the just the terminal here. I'll make it kind of small, just so you guys can kind of get a feel for what I'm doing when I'm working on it, but still want to keep the code up in front of the screen. So yeah, and I guess I'll say welcome if you haven't been here before. This is a project on GitHub to do AI research in Dungeon Crawl Stone Soup, which is a really cool, really difficult roguelike game that is open source and available. And it's a lot of fun to play. And these types of games remain an open challenge from AI research. There's actually, so NetHack is a similar game. There's actually a challenge right now going on using the NetHack learning environment to develop AI agents. And I think, yeah, you should check that out if you're interested. So our API is not quite as polished yet as that is. And we're also working on features that that API is not necessarily have planned for support, things like symbolic models of the state. So there'll be some differences between these two APIs. Yeah, so with that, let's go ahead and get started. So what I'm going to do is I need to first activate these. Oh, I just want to call out for people, if you don't already know, the documentation is pretty good. We've updated it a lot for the project. So if you go to the master branch, you click the docs badge here at the top. And then if you go to quick start, this has all been updated. We added a little bit more detail. So these has all the instructions for getting everything up and running. You shouldn't really need to do anything in the installation part. That's more if you want to not use the Docker image and create your own. So, okay. With that, we're going to run an agent, and first we have to activate the virtual environment. It's different on Windows, which is, I always forget how to do that. Okay, so we got it. And now we can call the fast downward planning agent. Okay, and so if we go here, I spectated it too early. This is a known bug. You just have to wait a second before you can spectate it. Okay. So we got the agent moving on our planning agent, and I'm just gonna check what. Okay, our agent died. I think it'll go ahead and start a new game automatically. And in a second, we'll spectate the new one. Kind of unlucky there, running into a bunch of monsters. So what we're gonna do is we want to try and do this. So last time we fixed an issue with the planner where basically there just was, a couple weeks ago we got a new research paper out that talked about some of the updates to the API, and it showcased this planning model. So if you all haven't seen it, if you go to models and then you go to fast downward simple, it's a pretty decent sized PDL file right now, and even with that, it's currently incomplete. So this file will only get bigger. But we're like 2,100 lines of PDDL, which is a language for describing environments. And so this has actions and all these things. It has all the monsters in here. I mean, there's 650 monster types, so that's part of the reason why it's so long. Anyway, there were some issues with this that we fixed, or at least believed we fixed. We're going to test it out as we start here today. And then we're going to basically continue iterating and see if we can get more actions online and working and things of that nature. And we kind of debug as we go, so we may realize we don't have something implemented and then we have to add it. So we have our agent here running along. We have our planning model, and what I'm going to do right now, we have the way that it chooses to go after our goal to go to the next level is I think there's just some threshold. So, and you have to excuse me, it's been 2 weeks since I've looked at this code since the last stream, so I've got to just bring my mind back to it. I'm sure all of you can relate to that. If there's any good reason to write good code, it's just for your future self, even if no one else looks at it. So here we're getting so this function is what's getting us the goals to just visit new tiles on the level that we're at. This get random non-visited non-wall player at goal. This is supposed to get us monster goals. It looks like the agent's fighting monsters. I think that's working, and we can also double check that. This is to get the plan. And here is a function to get the plan to reach the next floor. So this is doing some extra work to try and find the tile where the stairs is. But because of what we had fixed last time, we should be able to just give a goal. We want to be at the next floor. So, and this is what this goal is saying. So this goal selection function, this is what's being called in the get. So the get action, this is kind of the top level function. This is like the entry into the agent. And so this is what's being called by the API. So it's always getting the new state, and then it's doing some things here to figure out what action it's going to do. So if it already has a plan, it's just gonna well, this is just printing the plan. So right, there's some logic here. Let's what I want to find out is, so it's just calling this goal selection function, and if there is a new goal type, yeah, some nice logic here. Basically what this logic is saying is that only if you have a different type of goal, so if you're exploring and you have a plan that still has some actions in it, just keep executing those actions. But if you get like an attack monster goal and you had an explore goal, just scrap that plan and switch over immediately. So it's really simple mechanism here. And this should also work when the agent is, we want to give it a goal to do this. So but what I think we need to do is, so this is goal selection. This is supposed to return, okay, 2 different types. So this is monster, explore. I'm going to change this goal type to be descend. And so what is it doing here? It's, okay, it's just finding the place. Let's go ahead and print out what this goal is. In case we do run into issues. And I'm just going to say, make a variable here so I don't have to have this twice. And do lower place goal. Okay. We also have a goal to heal. Let's leave that commented out for now. Okay. Now, this is checking a threshold. Instead, because I just want to test this immediately. So what I want to say, and the way this logic is, it's going to return early if there's a monster. So, which that's generally the first thing we want to deal with is if there's a monster. So, what's nice is I don't need any logic to check if there's a monster or not. Oh, it went down to the next stairs. Look at that. So I think we didn't even have to test it. It worked because it reached the threshold. Okay. So actually what I'm going to do is I'm going to kill this so I can go back up and look. So new goal, player place dungeon 2. Plan action. So it actually generated a plan. Wow, so it's working. We did the GitHub issue we thought we solved last time. We did in fact solve because we're giving it just to go to the next dungeon, and it's done so. This is pretty neat. It generated a plan, you know, of traveling to the staircase and then traveling down, which is fantastic. So that was really the first thing. So we've kind of achieved the first thing we wanted to test here. What do we want to do next? So it looks like you ran into a problem, right? The agent kind of stopped, and that's because we got some exceptions. So now, really, the fact that we've gone to the next level means that we have to deal with the 3-dimensional nature of our representation. And why do I say 3-dimensional, right? It's a grid world. Well, it has multiple levels. And so it seems a natural way to represent it is to just add a 3rd dimension, which is the level you're on. And we're going to have to look at the code that's dealing with this. So we get an error. It might be because we're not updating the current place. So we're going to have to dig into the map data. Basically, okay, so what's it saying? There's a key error here, which I think makes sense. Okay. And what I want to do is, right, the first time this happens, let's see what happens. So position is x0, y0. Okay, well let's go through the code and let's take a look and see. I'm just gonna check you guys can see this, okay? Okay, it looks like you should be able to read the code. Awesome. It's kind of funny to see yourself on the stream. Okay. we need to go into game.py. And we need to look at, actually, I think cell map is really, yeah, the error is in cellmap.py. So the cell map, we have place and depth. I want to see where this is being used. Okay, it's quite a few places. So add or update cell. So what is this? This is saying if the current place is not in here, add to the current place. Well, where is current place being changed? Which function is this? Add or update cell. Okay. And I just want to check if this is the function that's actually being called. Yeah. Add or update cell. You know, what I'm going to check first is that when we get this player message and the depth changes, we need to change the current place. I'm sorry. Place, then depth, then XY. Is that what we have? Place, then depth, and then XY. That's right. So, I think this is going to be in game. In update, we're going to, yeah, let me look for update. Yeah, message from server, process raw state. Should be player somewhere. I'm going to look for it actually. Yes, process player. Name, title, place, depth, set current depth, set current place. So it looks like the place didn't change. And I'm just going to go ahead and print out that the depth is right here. To make sure that's right. And when this happens, when we set the current depth, it does it in cell map. But then we can get a key error. If current depth is not in this, and then it says if XY is here. So I think actually the player X and Y needs to be updated. And I don't think we need to go back and look at as it is, because that's the error I think we're seeing. You guys can't see it in this terminal because I know I've made the window smaller on the stream, but here what's highlighted is the player's position, but it looks like where the error is, it's trying to give the player's old position, so it hasn't reset at the right place to 0, 0, to those new values that the server sent us. So we're setting the depth and we're setting the place. Well, the place isn't being set because I don't think the server is, because the place hasn't changed. We're still in the dungeon. So what that means is we need to go back and find where we're processing the player, which I think is here. And do we have X and Y? I don't think we do. So this is all in player, right? Process player. We don't have X and Y here, and so that's the problem. So we have everything else, and I think part of it's we haven't run across this yet. You know, we should have gotten this warning. Unknown player datum. Did we get this? I don't think. Well, we just got a key error, so. Oh, you know what it is? It's because this is a nested thing. So it's not at the top level of the data structure that the server is getting us. It's this position tag. And are we ignoring that right now? Or maybe we are. Yeah, position. Well, let me print this out. But then even though we're setting self.agentx, self.agent.y here in game.py, I don't think we're updating it in the cell map. That's the problem. 100%, I think that's the problem. I think we just have to do self.cellmap. Do we have a function for it? I don't think so. We really should have a function rather than just setting the variables. That's generally not good style. Let's go to cellmap and do that. Let's add a function. Sorry, agent. Oh, really? Okay. Oh, I spelled it wrong. All right. And then back here, we need to do cellmap.set agent x. And all right, I think this is what needs to happen. Because I remember before we had this working where the player could go to multiple levels. And then I want to change, because we're testing new goals, I want to just go to the stairs immediately. Not have any threshold or anything. So I want to add something, because this is still kind of a test agent. I want to do self.player has seen stairs. It was false. And then I want to, and I'm iterating over these cells anyway. So just before this, I just want to, well, let me add it at the end. If cell dot, can I do this? Has stairs down? I bet I can. So in cell, what variables does the cell have? Yeah, it has stairs down. It's true. Then let's make the stairs down. Yeah. Okay, and then we can reference that here later. So instead of any of this, let's just say if self.player has seen stairs down, let's do this. All right, and so hopefully on some of these runs, what we should see now is that the player descends many levels, because as soon as they see stairs, they should go down. So this is hopefully going to be pretty exciting here. A new capability. Might get farther in the dungeon than we've ever seen for an agent. So I think it was deleting the old game. Looks like we're in. And there are stairs down, and it's down. So let's see if it fights. There's no more error, so I think we fixed that error. Looks like it's moving around just fine. And let's see if it takes another stairs. Well, this worm might give us a hard time. But you know, Minotaurs are so... Oh, wow. I was going to say Minotaurs are so strong, but look at that. Huge chunk of health gone. It's fine. Death is a part of this game. All right. That's awesome. So it looks like maybe something funny is happening. The map we're displaying looks right. Choosing player place. Oh, yep. I know the problem here. So it was choosing a goal to descend to the next level. We need to track which level the player is on. So what I'm actually going to do is change player has seen stairs down. I'm going to make this a dictionary where this is basically the key is should really be a nested dictionary. Just for now, I'm going to do key is level down. And sorry, key is the depth. Value is whether seen stairs down. I doubt we'll make it all the way down to dungeon level 15. By then we'll have to have a much better agent capable of handling much better things. So I think this is okay. This is temporary. And then what we're gonna do is here we're gonna say so we're gonna say if self.gamestate dot player depth not in self.player has seen stairs down dot keys, then we're gonna add it, right? We have to check for that key error condition. Self.current game state dot player depth is gonna be equal to true. I think this is this gonna work? Oh my god, I feel so rusty with my Python. Luckily you can just test things in a little terminal in PyCharm. So we can just say A is a dictionary. Can I just say A of 1 equals false? Yes, I can. But then if I try and do A of 2, it gives me the key error. Okay, so we're fine. So I think that should work. Are there any problems? The problem is later when we're going to go to use it. So, you know what I want to do is I want to say x, I want to populate this basically with all false. So for x in range 0 to, let's just say 50. I know we won't get that high, but so basically this is just saying we're just going to populate it all to be false. That way we shouldn't have to worry about key errors later, and then we can just, because down here we're going to have to query it, right? In goal selection function. So instead of saying if player has seen stairs down, we're going to do if player has seen stairs down, get the current depth. And so this will be false for every level until the player sees it. So let's run it again and see if we can get it. You know what? Yeah. Really should have committed sooner. I'm just going to make a quick commit. So what did we do? We fixed cell map key error when descending. Added new what is this? We added a new decision. I'm going to say added a new condition for choosing to descend in planning agent. Oh no. So now if you're following along on this stream, on this branch, I've just now pushed it, and you can go check that out. So let's run it. Okay, it's probably gonna exit out of this game. Yep, it's gonna start a new game. We're gonna wait just a second to spectate, and it's in. Oh, you know, I still have a thing with plants where it thinks they're monsters. Maybe it can just destroy this. Okay, hopefully it won't try to fight the trees. Nope. Looks like there's a lot of plants here. I'm gonna just restart. We'll deal with that later. Might even add an issue right now while this is running. So, well, let's watch it here. It's always exciting. Got a monster. So while this is happening, let's go ahead and add an issue. Or actually, I'll add an issue separately while you guys are watching. God, this is such a cool project. We really shouldn't print out discrepancy in player location anymore. I'm gonna just change that real quick. Well, first things first. Can't get distracted. There's so many little things to do. Let's add the issue. So new issue. The idea is that if we keep adding a ton of these little issues, hopefully folks who want to contribute to the project can find something relatively easy and try and work on it. So Can I give it a label? Oh, there's labels for help wanted. Cool. That's cool. So has it gone down yet? It says there's a stone staircase. Interesting. I don't think it has gone down yet. Maybe there's a bug in, oh, there's the stairs down. It should be going down right now. But then there's a monster. It has to fight the monster. Okay, so it's not going down. So something's happening. Player has seen stairs down. If oh, we're asking if it's not in the keys, but it's always in the keys now. That's the problem. No kidding. Because the way we initialized the dictionary above made it so we didn't need to do that anymore. We could remove that if condition. So, and then I wanted to remove that printout statement that there's a discrepancy. So let me do that. We're gonna have to search for that. Warning. Discrepancy in player location. We're just gonna comment all this out, I think. And with that, we're gonna restart because the player's never gonna go down. So we're gonna restart. It'll quit the game, start a new game. And the agent's running around. Let's see how low he can go. Oh, no plan, taking a random action. It's gotta open the door. Interesting. I think that's an issue with the way that it's looking for doors, which we could change that too. So I think in the planning agent, first of all, we don't need this anymore. That's just old code. As well as these. This is old code. And so here we're saying, I thought there was some threshold for visiting closed doors. Yes, if I is less than 4. So let's just change this to remove that condition. Okay. All right. I think we solved that issue that was causing on that level, but obviously we won't know until we get that level again, and I didn't have the seed for that level, so we're just going to have to hope we find it eventually later. So it's going to delete this game. And we're in. All right, it found stairs. It went down the stairs. Cool. Pretty quick. Killed some monsters. I'm really excited to see if it'll go down another flight of stairs. Ooh. All right, look at that. All right. Level 3. Ooh, I wonder how far we'll go. Oh, we're gonna get to level 4? Is this gonna work? No kidding. Dungeon level 4. Wish I could take bets. See how far we'd get. So if you don't know, as you get farther down in the dungeon, the monsters get harder. But the probability of running into harder monsters increases. There are some seeds where you can run into a surprisingly difficult monster on the first level, but it is quite rare. Wow. Yeah, player might die here. Ooh, maybe not. Ooh, player died. We should have gone berserk. That would have been cool. Awesome. Well, just let it keep running, and I think I'm gonna go ahead and commit because this is a good milestone here. And it means our planning model is good. So we've pushed that, and now what we really want to do is we want to start doing things like items. So I think let's make an agent that will pick up any item. Pick up every item it sees. Let's do that. That'll be simple. So get, let's say, nearest item pickup goal. And so for this, I think I think what I'm going to do with this planning agent, just to make the code a little bit more manageable, is I'm going to do a process game state via cells function. And it's going to do a lot of the work that this get random non-visible nominal player at goal thing will do. So it's going to iterate over the cells. If a cell hasn't been visited by a player, if a cell has a closed door, if a cell has stairs down, we're going to do all these things. And we're going to make these variables kind of at the top here. So I realize we have a variable overloading here. So let's refactor, rename this to be number of cells visited. And then let's do these three basically. And then I can just remove these. And so we're processing all the cells, and then we can, I think we can, nope. We can just delete all of this. Self.num cells visited equals the length of this. So we can just do this every time this is called at the end here. I know this is a little redundant, but you know, for now I think it's okay. This is not like final version of code or anything. If anything, this agent is just a debugging agent so that we can test our planning models are working and the API is working and things like that. So now we're really doing the work of checking to see if what this function is really doing. And yeah, I think this is everything we need to do here for the getting the location cells. So we gotta make sure we call this function every time. So in get action, let's make sure we call it here. And now we have this cell information. So for example, we can say whether or not a cell has an item when we process cells, and we can say if cell dot I think we're going to add two things, right? So if self dot just say found item, if this is equal to, and this will be the cell, so it'll be none. And then self dot inventory full. And so what we're going to do is I think we're going to see if self dot has, we have more things than that, because a cell, we're still in dungeon 1, huh? No stairs? Yeah, I guess we haven't seen any stairs down, which is kind of cool. It means our agent's getting stronger, right? They're already level 2. So has ring, stave, hand weapon, armor, missile, amulet. But you know, this should be in the PDDL. This should be in the PDDL. So if we go to the model, and we want an agent to pick up items, then let's look here. So you know what we're going to do? Let's just look at the current state, see what we're writing out for items. Um, so this has gold thing? Gold is not a thing. Interesting. Is armor a thing? No. Weapon? No. Item? No. So we're not writing out any items right now. And if we look at these, this is something we need to add. If we look at the predicates, there's nothing for item. But if we look at picking up items in the P2DL, I'm sorry, this is the wrong file. That's the wrong file. Should be looking at this one. Whoops, sorry about that. Ignore everything I said the last 2 seconds. Okay, so we have these types, we have item, and then we have like constants, right? So do we have gold? Golden rune, giant goldfish, golden dragon. Okay, we don't have gold. So do we have weapon? We have scrolls. We have weapon. It's a spell. It's an ability. So we have has potion, has scroll, has weapon, has armor, has food item. But these aren't being written out. So that's what we need to do, is go into game.py. And we need to look at them being written out. So and you know what? This is really getting into these functions where we get the state via P2DL. So we wrote versions of this that use vectors. We haven't done any reinforcement learning agents or any agents otherwise that would that use that yet, but we have them all here. So, well, most of the vector ones. We have 2 vector ones we still need to implement, and then we have these. So this is really what we need to work on now, is to write out these P2DL facts, and then we should update our fast hour planning agent so that it is calling these functions rather than the current function right now. And what this means is that the planning agent itself will really be the one that's just writing the thing to the file. It won't be a part of the game. So that's something we need to do. I wonder if we could just do like 5 minutes or so of this. Let's go ahead and do player stats P2DL. So we have a vector. We have this is a long thing. We have a player stats. There's a lot of player stats vector here, and it's basically looking at, I think, this player object, or sorry, just these player facts. And so we're just gonna have to take this, and there's quite a bit, and turn it into P2DL. So I'm going to copy this. So let's go ahead and try this. Okay, so we paste this. It's huge, obviously. So this is player stats in the same order. So I think these... All right, we're on level 2. Awesome. And our agent is a bit stronger than he was last time. So, okay, these player stats... See, a lot of these have their own P2DL facts associated with them, right? So is this, yeah, this is the right model. So we have things like player health, which is a qualitative quantity. So what that, so and we're just gonna have to go through one by one and get these to work here. So can start with, so basically all of these three are gonna condense into this one. So I'm gonna take these three out, and we're just gonna say, so we're just gonna say player stats equals this, and player health and we have the level up thing we need to add here. Okay. There's that too we need to do. Okay, cool. I'm gonna go ahead and make an issue. Okay, make a new issue. So what's this? Well, the issue is that the agent doesn't get the issue is that the agent freezes when leveling up because of SDI choice. And honestly, I'm just gonna take a screenshot right now to put this in the yeah. Yep. I think I have to save this. That, and then do we get an error message? Let's just go ahead and exit that anyway. But then we should have gotten an error message, so I'm going to put this in the issue. Ooh, it was hanging there for a while. Yep, we don't have the error message because the terminal ran out. Okay. Just going to submit a new issue. And okay, so we have that. Let's see if we can figure this out real quick. So if we look at the fast downward simple, right, under constants. Okay, nope. It's way higher, I think. Yeah. So under constants, at the top here, we have these. None, low, medium, high, high, maxed. So we basically need to write a little function to pick one of these values. So player, so what I'm going to do is I'm going to do this. Whoops. Let's do this. That didn't work as well. That's fine. Actually, I can just do this. Awesome. Not player. Don't need player. Okay, so quantitative choices is equal to this. And what we want to do is, I think we want to say, there is a math way of doing this. This is kind of nice. So the number, the bins we have here is equal to the length of quantitative choices. And so I think what we want to do is we want to take the players. Yeah, I'm a bit brain dead for this one. I know what I want to do. There's the exact choice of doing it. Basically, we have to take these bins and we can just divide the current by the maximum, I think. So just want to double check here. So let's just say current is equal to 32. Max is equal to 125. If we do current divided by max, what is that going to give us? 0.25. If current is more like 100, that's going to give us 0.8. And so what we want to do is convert that number into the bin, into like the index. That would be ideal. So I think that we can get the bin size by just doing 1 divided by 7. I think that's the bin size. So then basically there's a one line way of doing this. I think if we take an index, we do cur divided by I think is it just as easy? I'm wondering if we just do, I think it's just current divided by max times 7. If I'm crazy, and this is the dumbest thing ever, don't kill me for it. Is it times 7? Yeah, I think it should be times. So with these the other two examples, right? If I do 0.256 times 7. Oh, right. What am I thinking? So then, we could just chop this off. So we just do this, and then if we turn this into an int, right, it gives us 1. So is this right? If we have 32 health, is our health low? Because this is what's at index 1? I think so. And then let's say our health is like 73 out of 125, right? That feels like medium low, maybe even medium. We get 4. 0, 1, 2, 3, 4. Medium high. Is it above halfway? I guess it is above halfway. Yeah. Let's try 55. Let's do 55. We get 3, which is medium. Let's do like 45. We would get medium low. So I think this works. So I think all we have to do is say, so we're gonna add a thing. So I'm gonna add this at the top because we're probably gonna use it multiple, well, actually let me keep it in that order because this is the variable that everything's gonna be added to. This is some stuff, and then we'll start adding knowledge here. So we're gonna say player stats.pddl dot append, and this is gonna be, if we go back to our planning model, I think it's gonna be player, the predicate. So can I wish I could collapse that. If we go to predicates, player health, right there. So what are we gonna do? We're gonna go here, we're gonna say player health. We're gonna fill this in. We're going to give it this function. So what is this? It's an integer, the final value, and it's gonna be self.player current HP divided by self.player max HP max. And I think we're just gonna ignore real HP for now. I don't know how to deal with that. So we've got player health. We got the first PDDL value. And then we're gonna do something similar for MP. So we can let's just go ahead and do that now. So I'm gonna do player, and let's just make sure the thing all works out, right? So we have player health. Do we not have player magic? We don't really have magic yet. Yeah, I'm gonna go ahead and say magic. Play player mana. I don't think they use that word, mana. I'm gonna say magic points. I think that's what it uses. Player magic points. And we're gonna do this one as well. Player magic points. And this is gonna be MP out of MP magic max. So then these are all taken care of. And we don't even need, wait, do we? We need this times the length of quantitative choices. So basically inside here we have to do this, but let's make sure that we enforce the order. Cool. And well, this is a extremely, yeah, we don't have to, is there any errors? Oh, it doesn't have these. No, it does. Okay, there's no errors. Cool. This is pretty great. So we're gonna stop here. I'm gonna do a commit. What did we do? We started writing get player stats PDDL. Awesome. So I've pushed that. Let's run it to make sure things work. I think they do. but it, you gotta actually check. So nothing's using this function yet, so I think, ooh, still got a problem here. Okay. So let's make sure it runs, and then, because I would like to put this back in the master branch, because we just straight up fixed some things, right? It's ending this game. Oh. And it looks like it's having trouble ending the game. It's kind of weird. It's abandoning character. Oh, what's the issue? Is there an exception somewhere? Well, what is this level? Oh, because it wants to end. Oh, it's stuck on this. Yep, it's stuck on this. That's right. So we gotta finish that thing. That's why I couldn't do anything. Just run it again. This should start a new game. Awesome. Let's hopefully it'll find some stairs pretty soon. Wow, a lot of doors here. Well, we didn't really change any of this code, so I think it's gonna work. Thank you all for tuning in. My plan is to keep doing these on Tuesdays. I don't know what the time is gonna be. Just gonna kind of be flexible, but sometime Tuesday evenings, probably between 5 p.m. Eastern time at the earliest, maybe even as late as like 10 or 11 p.m. But yeah, and if you want to keep following these, subscribe or leave comments or post issues on the GitHub or anything. But thanks for tuning in, and it's fun. And check us out for the next streams. All right, have a good night.